So the first question, it looks like that we have a conceptual question. And it says, when a ball is thrown vertically upward, it continues upward until it reaches a certain position, and then it falls downward. At the highest point, what is the ball's velocity? What is its acceleration? Okay, so didn't we just describe before, if we take an object, a ball, toss it upwards, it goes up, 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 and then down, 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 right? So it goes up, pauses for a brief moment, and then comes back down, right? So what is the velocity at the highest point? 0 meters per second. And what is its acceleration? Well, for all free-falling problems, including when you're throwing a ball up in the air, it's going to be acted on by gravity. So we're going to have the acceleration due to gravity acting on the object in all of its trajectory. So at all points in its trajectory, it's going to be the force acting on it will be the force due to gravity. So therefore, we'll have the acceleration due to gravity acting on the object, which is negative 9.8 meters per second squared. Well, wait a minute. Wouldn't it be 0 at this point, the acceleration? No, it won't be. If it's got 0 acceleration here, then, hey, you know what? It wouldn't be falling back down, because if it goes up, 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 and then there's no acceleration, no change over a certain amount of time, wouldn't it just like hover right there? It would just stop and it would just hover. The reason why it comes back down is because of the acceleration due to gravity. At all points in the object's trajectory, it will be acted on by the acceleration due to gravity, which is negative 9.8 meters per second squared. Okay, so for question 2, suppose you throw a ball straight up into the air at 20 meters per second. Describe the changes in velocity of the ball. Describe the changes in acceleration of the ball. Between which 2 seconds does the ball reach its max height and hit the ground? Okay. So we know that initially, what's the ball's velocity? 20 meters per second. What's its acceleration? Negative 9.8. The acceleration throughout the entire ball's trajectory will be negative 9.8. So hey, you know what? We're just going to fill this out. Bam! All the way down, negative 9.8. So, for every 1 second, the ball's velocity will change by negative 9.8 meters per second. That's what this means again. So, after 1 second, we have, what's the velocity? It would just be 20 minus the 9.8, which gives us 10.2. Okay, so after 2 seconds, what's the ball's velocity? Well, 10.2 minus 9.8, which gives us 0.4. Okay, and then after 3 seconds, well, we have the 0.4 minus the 9.8, which gives us negative 9.4. Minus another 9.8, negative 19.2. Minus another 9.8, negative 29. Minus 9.8 will give us a negative 38.8. Okay, notice that these numbers are a little bit, they're not as nice looking or as friendly looking as what we had before when I was describing the object's trajectory. So, okay, it kind of was like nice, the idea that, hey, you know what, we minus 9.8, and then we got minusing another 9.8 over here, we got 9.8, and then minusing another 9.8, we got 0, and it looks a lot more symmetric over here, right? Versus this, it's not as like nice and friendly as looking, right? Well, there's a reason for that. All I did here when I set up this problem, all I did here was I took 9.8, multiplied it by 3, and I got 29.4. I know that when I subtract 9.8, hey, you know what? I'll get 19.6, and then subtracting another 9.8, you get 9.8, and subtracting another 9.8, you get 0. I could have multiplied this by 4 or 5 or whatever the case is, and I just made the numbers so it's super simple to actually see for a introduction. I purposely did that. But so that was specifically for 29.4. So that was specific for this number of 29.4. I said that this is our initial velocity, and that was the logic behind it. But now we're given an initial velocity of 20 meters per second. Okay, so this is just our situation right now. We're just given this, and now it's just a little bit messier looking, but 2 questions. Between which 2 seconds does the ball reach the max height? Well, what do we know about the max height? Isn't the velocity just going to be 0? So between which 2 seconds will it reach the max height? Doesn't it make sense that would be between these 2 seconds? Max height? Because this is in between, well, 0 will be in between here. Maybe it's a little bit closer to 2 than it would be to 3. Okay, and at between which 2 seconds does the ball hit the ground? Okay, maybe that's a little bit trickier, but don't we know, didn't we see before that this is very symmetric? So, if I toss it up at 29.4 meters per second, when's it going to hit the ground? When it's going to hit the ground at 29.4 meters per second. That's the velocity, because it's a very symmetric path that it takes. So, we know that the ball goes up at 20 meters per second. You know what? It's going to come down and hit the ground at negative 20 meters per second. So it's going to hit the ground between the 4th and 5th second. Well, wait a minute. How is it possible that actually reaches negative 29 and negative 38.8 meters per second? Well, maybe this is the situation for this problem. Maybe we didn't actually toss it up and have it come straight up and straight down. Maybe what we did here was we were on a cliff, and we tossed, maybe we're at the edge of a cliff and we decided to toss our object straight up and then it comes down. Notice that this is the level of the ground over here. So it might have, hey, you know what? It reached the point of the velocity over here at 0 meters per second and then down over here. Actually, I guess if this is the height that we're throwing it at, that would make more sense that it would be negative 20 meters per second here. And then over here, maybe we'll actually see that this is when it reaches the 29 or negative 29 meters per second over here. So, hey, you know what? It's just one of those situations where maybe we tossed it up and it came down farther. We're not really going to see that too much in this course. Maybe your professor or your teacher might trick you a little bit on something like that. But just know the idea that the object's trajectory is very symmetric. What you toss it up at, the initial velocity over here, it's going to equal to the same velocity at the same height.